By the end of this module, you will have a basic understanding on air filter application, how it works traditionally, and with Danfoss solution. The key benefits of using a VLT HVAC drive in air filter systems. Let me start the module with a brief description of the air filter application. Filter control systems are constant air volume systems used when there is a necessity to supply clean air in precise amounts. Filter control finds its application in hospitals, nuclear plants, pharmaceutical facilities, high-technology manufacturing, clean rooms, and other institutions where clean air is essential. Let me now explain the air filter application in a constant air volume system to you. Take a look at the illustration. The constant air volume supply fan blows the air across the heating and cooling coils as required and through special microfilters. These filters remove the contaminants from the air before it enters the control zone. Sometimes, these filters are also fitted with the exhaust fans, which remove the air from the zone and channel it to outside. These fans need to be sized to provide design flow when the filter is dirty and has its maximum resistance. We shall now look at a traditional air filter control system. Traditionally, no control is utilized in true, constant air volume systems. Once the system is balanced, no modification is made to the system or the fan. When the filter is new or unclogged, the resistance or the pressure drop across the filter is low, and the flow of air is in excess, comparing to design condition. Take a look at the graph. Please notice that when the filter is clean, there is an excessive flow of air, compared to the desired one, and the pressure is low. This excess of airflow increases the energy consumption, and decreases the life of the filters. As the filter becomes clogged or loaded, the resistance or the pressure drop increases to expected level, resulting in the reduction of airflow until the filters are replaced. You can notice from the graph that when the filter is clogged or loaded, there is a desired flow of air with a higher pressure. A differential pressure sensor is commonly utilized to monitor the filters and to identify the filters which need to be changed. You have seen that, in the traditional method, there is wastage of energy. How can we overcome this wastage? That is where Danfoss solution comes into play. The VLT HVAC drive provides the precise airflow, regardless of the condition of the filter. The VLT HVAC drive provides constant air volume in the system by using a static pressure sensor, which helps maintaining a constant static pressure. Using a static pressure sensor to measure the duct static pressure in the downstream of the filter, the VLT HVAC drive provides a constant system airflow. Let me elaborate on how this is done. When the filter is clean, there is not much pressure drop across the filter, and the flow is not affected much. Hence the VLT HVAC drive operates the fan at a lower speed and less energy. As the filter becomes clogged, that is, as it loads, the pressure drop across the filter increases, and this is detected by the pressure sensor. The VLT HVAC drive automatically increases the speed of the fan in order to compensate for the effect of the dirty filter, restricting the airflow. Thus, a constant volume of air is maintained. The graph shows the meeting of the various fan curves with the system curve, and the corresponding variation in pressure. You can also see from the graph that the pressure is increased when the clogging or loading of dust particles increases. Similarly, you can see from the graph that the pressure is reduced according to the reduction of dust particles in the filter. So, what is the advantage of this solution? By using minimum fan speed, when the filter is clean, higher than necessary airflow through the filter is prevented. Hence, the dust holding capacity and life of the filter is increased significantly. Also, when the fan operates at slower speeds, significant savings in energy consumption, together with improved overall performance, are achieved. We just saw that the Danfoss VLT HVAC drive facilitates energy savings in the application. The diagram shows the difference in energy consumption when using a fixed-speed fan and a fan controlled by a VLT HVAC drive in association with a pressure sensor control to ensure that design flow is delivered to clean room at all times. The energy savings achieved by using the VLT HVAC drive are obvious. Let us summarize the main benefits of using a VLT HVAC drive in an air filter control application. Here they come. The VLT HVAC drive provides precise airflow through the filter, regardless of its state. The VLT HVAC drive provides a constant system air volume by using a pressure sensor to measure the duct static pressure in the downstream of the filter. The dust holding capacity and the life of the filter is increased significantly. Overall energy savings improve the performance of the system.